Hello viewers, you are welcome to my YouTube channel. Let's see the way we can solve this question on the board. It is a problem on joint variation involving percentage increase. The question states that given that the energy E varies directly as the resistance R and inversely as the square of D, obtain an equation connecting E and R given that E equals 32/25 when R equals to 8 and D equals to 5. Hence, find the percentage increase in the value of R when each of E and D increases by 3%. This is a question involving a joint variation. A joint variation. So let's first of all interpret this statement using the sign of variation or proportionality. So this question can be solved as follows. Solution. We have the parameter E or the quantity E which varies directly as the resistance. That means our E varies directly as the resistance. Also, E varies inversely as the square of D, which can be written as E varies inversely as the square of D. So we are having two variations in which we have the first one, E varies directly as R. The second one is indirect or inverse proportion, which is the same as E varies inversely as the square of D. So we can jointly express the two variations. We can jointly express the two as, so jointly expressing the two variations, we are going to have E varies directly as R and inversely as the square of D. So this is the equation, this is the variation connecting E, R and D. But we are going to convert this variation to an equation by introducing a constant of variation. A constant. We want to convert it to an equation. So if we introduce a constant, we are going to have E equals KR divided by D squared, where our K is called the constant of proportionality. So let us find the value of this K, because we want to find the value of K that can be substituted in this equation, which will connect the whole of these three parameters all together. So we are given the following values. That find the equation connecting E and R, given that E equals 32. So if E is equal to 32, that means I'm going to substitute here 32. First write E equals to 32/25. And what is the value of R? 8. The value of D is 5. We want to find the constant of variation. K equals to what? So let's substitute. My E equals 32 divided by 25 equals to my K times R, which is times 8, divided by D squared. That means I have divided by 5 squared. Are you there? So that means this one can be written as well as 32/25 equals K times 8 divided by 5 squared is the same thing as 25. So since I'm having the same denominator on both sides of the equation, I can simply say 25 cancel 25. So if I want to find my K, I will have 32 is equal to K times 8, 8K. Dividing both divided by 8, we are going to have 32 divided by 8 is equal to 8k divided by 8. 8 cancel 8. So therefore, my k is equal to 32 divided by 8 will give us 4. So let's substitute this value into this equation. So the equation will now become E equals k. Where we find k, we write 4. So that means the equation, let me clean this. So therefore, we are going to have E equals, the value of my k is 4. I'm going to write here 4r divided by what? D squared. So this is the equation connecting E, R, and D. This is the equation connecting E, R, and D. We are done with the first part of the question. The second part states that, hence, find the percentage increase in the value R when each of E and D increases by 3%. Now the question we are going to ask ourselves is, this place in this equation here, the E here is written independently. It's written separately, standing alone. But the question here focuses on variable R. Now let us find the percentage error, percentage increase in the value of R. That means we make this R the subject of this equation. We try to transform this equation so that our R will become independent. So if we write it that way, if we transform our equation, we are going to have R. This implies that R equals E cross multiply. We are going to have E times D square, E D square divided by 4. So this is my equation expressing the value of R. Now the question states further that the percentage increase in quantity E and D is what? Is 3%. When we are dealing with increment, percentage increase, let's say for instance, we have something like this. Our 100 is always taken as what? As our basis. So if 100 is taken as the base, if you are having percentage increase, simply add the what? The increment, that value that has been shown as the increment there. You add it to 100. If I'm having 2% percentage increase, so that means I'm going to have just plus 2. If this one is my old quantity A, so my new quantity A will be what? A equals new A will be 1/2% of the old A. Because I have percentage increase of 2. If I have percentage increase of 5, just add 5 to 100. Then the new quantity A, the new A will simply be what? 105/100 of the old quantity A. So the same thing is applicable to this question. We are having percentage increase in E and D. So let our D1 represent new D. Let E1 represents new E. Then if E and D changes, definitely we are expecting a new value for R. If E changes from D to D1, and we have from E to what? E1, definitely this R will also change to what? R1. Because R depends on E, it also depends on D. So for the new changes, and we are having new value of E, E1, we are having a new value of D, D1. So that means our R will change to what? A new value, which is what? R1. So our R1 is equal to a question mark. Now let's solve further. If D1 is our new D, therefore with the percentage increase of 3%, that means your new D, which is D1 will give us 103/100 of D. That is 100 plus 3, 103. So we are going to have D1 equals 103% of D. Why? With percentage increase of D. Percentage increase of 3. Therefore, our E1 here is the same thing as 103% of the old quantity E. Because of what? Because of the percentage increase of 3. We have with percentage increase of 3. So consequently, because of the changes we have, consequently our new R is what? R1. So we have here new R. So our new R will now be, in this equation we are going to have here R1 is equal to E1 times D1 squared divided by 4. R1, new value of R, R1 is equal to the new value of E times the new value of D squared divided by 4. So let us substitute these expressions. So we now have is equal to E1. What is my E1? My E1 is 103 over 100 of E. I have 103 over 100 of E. Then times my D1 here is what? 103 over what? 100 of D. So you substitute D1 equals this. 103 over 100 of D divided by, I'm having here square, then everything divided by 4. So let us try to simplify this expression as possible. So this one can be written as 103 divided by 100, close bracket, open bracket again, 103 divided by 100 with square, because this 103 will be affected by the square, this over 100 will also be affected by the square, then this D also will be affected by the square. Remember we have times E here as well. So we have here times E, then I have this D square, I have times D square. Everything divided by 4. So if we solve further, look at this expression for R. What is my R? My R is equal to what? ED square divided by 4. And in this equation, I have what again? I have ED square divided by 4. So we are going to replace ED square divided by 4. We replace it by R. That means the value of R1, the new value of R, which is R1, is also what? Dependent on the new value, the old value of R, which is this. So if we substitute, therefore, my R1 will give us 103 over 100 times 103 divided by 100, 103 square divided by 100. 103 square divided by 100. Remember, we still have another 100 because we have 100 times 100, which is 100 square. So let's just try to write 100 there. Then this one will now give us times 1 over 100 times, we are replacing ED square over 4, we are replacing it by R. So if I replace by R, I'm going to have times R. Are you following? So therefore, we now have again R1 is equal to 103 times 103 square divided by 100 times 100, close bracket, times 1 over 100 R. So with the help of our calculator, not to waste time, we have 103 times 103 square, close bracket, divided by 100 times 100. We have 103 times 103 square divided by 100 times 100 is going to give us 10,000. So I have divided by 10,000, which is the same thing as 109.27. 109. So the whole of our expression in this bracket is 109.27. So I have R1 equals 109.27. This times 1 over 100 can be written as 1 over 100 of R. So therefore, this one can be written as R1, anything over 100 is in percentage. If I have A over 100, I can express it as A%. If I have D over 100, I can write just D%. So I'm adding here over 100. So that means I can write my R1 as, therefore, R1 equals to 109.27% of R. 109.27% of R. That means the new value of my R is equal to 109.27% of the initial value of R. So therefore, that means there is an additional value to this 100 here. When you say 109.27, that means if you add 9.27 to 100, you are going to get 109, because our base is always 100 with respect to percentage. So if you have 100 and you have 109.27, that means the increment, which is the percentage increase here, is simply, therefore, percentage increase in R is equal to 9.27%. Percentage increase in our R, because the new R is 109.27 of the old R. So the increment is just this additional value to what? To 100. Our additional value is just 9.27. So that means we have 9.27% as the percentage increase in R. That is the solution to this problem. So that's the solution to the problem. So the value, the percentage increase in R is simply 9.27%. Please don't forget to like and comment on this video, and also try to share the video with your families and friends. Thanks for viewing.